Here's another triangle congruence theorem called hypotenuse leg. If you get a problem like this, these are overlapping triangles. If you look at it carefully, we can actually separate out these triangles and draw them separately. That's what I would do in general whenever I get a problem like this. I would draw one like that and the other one like this. And if we look, one of the triangles is W, Z, Y, and the other one is X, Y, Z. And what is given to us? WY and XZ are congruent. So WY and XZ are congruent. Then we know WZ and ZY are perpendicular, which is right there. XY and ZY are perpendicular, which is right here. And then if you look on the original figure, this ZY is a part of both triangles. So we can state that ZY is congruent to ZY. Now, this is not side angle side, but when we have a right triangle, if the hypotenuse on both triangles are congruent, which would be WY and XZ, and then if one of the legs, so in this case ZY congruent to ZY, if that's true, then the two triangles are congruent. So we're going to prove the two triangles are congruent, and again, what you should do is separate them and show that we have our hypotenuse leg here. And for our proof, it does take a little while to get through this one because first of all, we have to prove that the two triangles are right triangles. So we start off with what's given. That gives us our hypotenuse, and we have this given as well. And if these right angles are here, if the lines are perpendicular, then we know that right angles are formed. So Z and Y are right angles. You can say definition of perpendicular lines, or you can state perpendicular lines form right angles. Since these are right angles, we can state that the two triangles are right triangles, and that's the definition of a right triangle. Now we want to do our leg, so we state that ZY is congruent to YZ, or you could just say ZY is congruent to ZY by reflexive property, and then our last step is that the two triangles are congruent by hypotenuse leg. For this next example, and it's kind of hard to see just because of the colors, but we're told RP and QS are perpendicular and PQ and PS are congruent. So we see these markings here. I'm going to zoom in on that real quick just so that we can look at it a little bit better. And let's just zoom into it. And if we look at this carefully, we can see that they share this angle right here, and that these sides are congruent. And again, this is a side by side, so we can state that that's congruent to itself. This is not hypotenuse leg, but it is side angle side. So in this case, we can use side angle side. So I think this one's more of an informal proof. We want to know which postulate or theorem to conclude that the two triangles are congruent. In this case, we would state it would be because of side angle side there. So we know that those two sides are congruent because it's given. Reflexive property tells us RP is congruent to RP, and then because of the definition of perpendicular lines, we know RPQ and RPS are right angles, and they are congruent. So we have two sides and the included angle. That would be side angle side. And now for this last one, you don't really need to redraw this. What I would do is I would look at it and I would go, okay, it's a side by side, so we know BC is congruent to BC, and we have the hypotenuse on each triangle congruent. We know they're both right triangles, and we have a leg congruent on both, so we're going to use hypotenuse leg here. Okay? So you can redraw it, but in this case, it's not super necessary. All you need to recognize is that the BC here is the same as the BC here, and that gives us our hypotenuse leg. So we go back and we redo it. We want to show that ACB and DBC are congruent. We start with a hypotenuse, which is AC and DB being congruent, and that was given to us. Then we would state that the lines are perpendicular, which was also given. Since those lines are perpendicular, we can state that those angles are congruent and that they form right angles, or right triangles rather. Now that we've done that, then we can state that BC is congruent to BC by the reflexive property, and we have our hypotenuse and our leg, so therefore the two triangles are congruent. And we're done here. Thank you.